In this video lesson, we are going to cover the first part of inscribed angles and arcs. So for a little review, we're going to review arcs first. You need to recall that the measure of an arc is equal to the measure of the central angle whose sides intersect the endpoints of the arc. So if you have a circle like this right here, the endpoints intersect the circle, and then the central angle is in the center of the circle. And the measure of the arc is equal to the measure of the central angle. An intercepted arc is any arc of a circle that has its endpoints included in the sides of an angle that is called the intercepted arc. So, for example, here, the circle has its endpoints included in the sides of the angle here. So we have A and B is the arc, and the angle here is ADB. So we would call the intercepted arc is the arc that comes out from the angle. An inscribed angle is when an angle has its vertex on the circle and its sides are the chords of the circle. So, for example, the angle itself, so angle D here, has to be on the circle. So angle C would not be an inscribed angle. It has to be on the circle, and the endpoints also have to be on the circle in order for it to be an inscribed angle. The vertex that lies on the circle has a smaller measure than the central angle. So here, for example, here are 2 points that lie on the circle. This is our inscribed angle. The inscribed angle is going to be smaller than the intercepted arc. So here it says which angle is an inscribed angle and which is the corresponding intercepted arc. So remember, inscribed angles have to have their points on the circle. So here we could say that angle MJL is an inscribed angle, and then we would say its corresponding intercepted arc would be ML. And then another inscribed angle would be angle, we can't say MKL because K is not on the circle. Remember, it has to be on the circle. So again, we're looking for points that are all on the circle here. So like here we have G, I, and H, but H is not on the circle. So actually that's our only inscribed angle, MJL, and the corresponding intercepted arc is ML. The inscribed angle theorem says that the measure of an inscribed angle is equal to 1/2 the measure of its intercepted arc. So remember earlier when we were saying that the inscribed angle is less than the intercepted arc, it actually has a specific amount that it's less. It's half of what the intercepted arc is, or you could say the intercepted arc is twice the inscribed angle. So depending on what information you're given, if you're given the intercepted arc, you would divide by 2 to get x. And then if you're given the inscribed angle, you would multiply by 2 to get the intercepted arc. So for example here, this one says, what is the measure of an inscribed angle whose intercepted arc has a measure of 100 degrees? So here's the intercepted arc right here, these 2 points. So the inscribed angle is x right here. So remember, the intercepted or the inscribed angle is half of the intercepted arc. So we're just going to take 100 and divide it by 2, and we're going to get 50 degrees. Here it says use the inscribed angle theorem to find the value of x, the measure of the intercepted arc. So here we're given the inscribed angle, and we want to find FD, the intercepted arc right here. So since we're given the inscribed angle, we know that the inscribed angle is half of the intercepted arc. So now we want to actually take double 64. We want to take 64 and multiply it by 2, and that would give us 128 degrees. So the intercepted arc, FD, is going to equal 128 degrees. Here we want to name an inscribed angle that intercepts arc AB. So here, AB. Remember that the inscribed angle has to lie on the circle, okay? ADB does not lie on the circle, so that can't be it. ACB doesn't, so the angle has to be AEB, since A, E, and B all lie on the circle. Here it says, given circle C with diameter DB, what is the measure of angle ADB? So I'm wanting to know what this angle is right here. So we can see that it's an inscribed angle, so we know that it's going to be half of the intercepted arc, AB. So what we first have to do is find AB before we can find ADC. Now the way we can do that is, here it tells us that DB is a diameter. Okay, since it's a diameter, we know that DB, the arc, is going to equal 180 degrees. So what we can say is that DA plus DB has to equal, DA plus AB has to equal 180 degrees. We already know that DA is 110 degrees, so that means that AB, take minus 110, that means that arc AB has to equal 70 degrees. So we know that this is 70 degrees right here. Now, taking the intercepted arc theorem, we know that angle ADB is half of arc AB. So we're just going to take 70 and divide it by 2, which gives us 35 degrees. So we know that angle ADB equals 35 degrees. And that is the end of Inscribed Angles and Arcs Part 1.